34. I got 34.573 or 537 times 10 to the power 3, okay, pounds of force. Okay. So this is to prove to you the concept regarding rule number 1. Okay, we pick the entire T section because of rule number 1, right, which states that the shear flow must distribute throughout the entire section of the beam. Are we clear? So this is a very important concept that you have to know. Okay, right. So the next problem that I like to do, okay, and this is part of the homework, and initially it might look daunting, but again, once you understand the concept, it is not that bad. Okay, so this is from the homework. So example number 2. I need to check anyone have any question. Oops. Sorry. I did something silly. Okay, I have no questions. So this is straight out from the homework. And now our as I said, the way I ask question in term test and final is I do add on. Okay. And add on not necessarily things that you don't know. Okay, but things that you probably have seen before. So this is one of the question, which is question number 3. And hold on, I'm lifting the images. Right. Okay. So the beam is made from 4 boards nailed together. Okay. If the nail can each support a shear force of 100 pounds, determine their required spacing S prime and S if the beam is subjected to a shear of 700 pounds. Okay, so that is what is given to us. Okay, so I'll write other information. So we know that V is equal to 700 pounds. And we are given that the fastener resistance force is at 100 pounds. And we were asked to determine S prime and S. Okay, so over here is our S, over here is our S prime. Okay, so the formula we are going to use is Q is equal to VQ over I, which is then equal to fastener resistance force, and then we are going to divide by spacing. Okay, so I'm not going to waste time finding I. Okay, so I is equal to 337.43 inches to the power 4. And then the y bar, the centroid, is equal to 3.3548 inches, and from the top. Okay. So we have, let's see what do we have. The shear force. We know the I. We know the fastener resistance force. We are asked to determine the spacing. We need to know what Q to use. Okay. Again, first moment of area comes back. Okay. Okay. So to do this, we have to again design the shear flow. I repeat again, we have to design the shear flow. Okay. So now I'm going to sketch. Okay. I'm going to draw a sketch of the structure up to the centroid. Okay, so I have something like this. On the side. And then I'm going to sketch the center part, the major web, up to the flange. No, sorry, up to the geometric centroid. Okay. So I'm going to draw a line, a green line across. Right. So this is our geometric centroid. We know that we have fastener going through here, another fastener going through here, and another fastener going through here. We know that. Okay. And where it will fail over here. Failure point is at the joint that it will fail. Okay. Okay, so this failure region. Then we are going to construct our shear flow. Okay, that's why it's good to learn thin wall analysis first. Okay, if you look at the textbook, they do thin wall later. Okay, which is wrong. You have to do thin wall first, or not, you don't know how to design the shear flow. Then now I'm going to design the shear flow. Major web, control the flow. Terminal 1, terminal 2. This one over here is not a terminal, but it's a junction. And you'll see that. Yeah, it's a junction. Okay. So from here, okay, we want to look at the first thing we're going to do, we like to determine the failure. Okay, determine S1, S first. Okay, we're going to determine it. So we like to determine S. Okay. So if you look at S, this is the nail that highlight now that is affected by S. Okay. So the thing is, what is the first moment of area? Okay. So the first moment of area that we have to consider is only this. You don't need to consider from T2. Okay, you need to only consider T1. Why? Because T1 and T2 are not linked at all. Right? if the failure, so if the failure I call this failure 1, and over here is failure 2. All right, failure 1 is affected by terminal 1 and the shear flow across the entire member. Failure 2, initially the shear flow will start from where? T2. Yes or no? Okay. So now we know to determine S, okay, we only need to consider the orange shaded area. You don't need to consider at T2 because T1, the failure will affect F1. Yes or no? Okay. So with that, we now are going to find the first moment of area. Okay, QZ. So the width is equal to 1, right? The depth is equal to 3. And the Y bar is 3.3548 minus by 3 divided by 2. So this will be equal to 3.3548 minus by 3 over 2. And 1 is equal to 5.5644. Okay. So once you have QZ, everything seems easy now, right? So we are given V is equal to 700, 5.5644 divided by second moment of area, which is 337.43. And this was equal to fastener resistance force, which is equal to what? 100. Now it's single shear, yeah, because it's only one failure point for the fastener. And then we divide by S. So from here, S will be equal to 100 times by 37.43 divided by 700 divided by 5.5644. So it's equal to 8.663. Okay, so we have 8.663. And this is inches. Okay. So we find S. Then next we want to consider S prime. Okay, so determine S prime. So when we determine S prime, you watch how the shear flow are moving. Okay. So S prime is affected by failure 3 surface, right? Failure 3 or failure region number 3. So failure region number 3, the area that you have to take, right, will be bounded by this blue line, the first moment of area you have to take. Because the shear flow from the left and the right side, right, will come into the junction and flow into the major web. Okay, so bounded by the blue region. Okay, bounded by the blue region. So from here, we have to consider again our first moment of area. So QZ will be equal to twice, okay, 5.5644, right? Twice is because one is on this side, the other one is on this side, right? So we remember the small orange region. Now we have two of those. And then we have to plus, okay. Now the other geometry now, let me get this image down. Right? So from here, the width is 10. The depth is 1. The y bar is equal to 3.3548 minus by 1 divided by 2. Okay, so 3.3548, 1 divided by 2. Okay, so this will be equal to 2. So 11, so 2, 5.5644, 11, 11.1288 plus 3.3548 minus 1.5 times 1 times 10 is equal to 28.548. Let me do it again. 3.3548 minus 5.5 times 10 times 1, 28.548. So this will be equal to 11.1288 plus by 28.548. So it's equal to 39.6768. Okay. So the same thing, right? So you find the S, so this is equal to 700 multiplied by 39.6768 divide by 337.43, and this is equal to 100 divided by S prime. Okay, right? And we know S prime has to be smaller because it's taking more shear flow.